Welcome everyone to our webinar on reactive UI state management. This time we have a really interesting topic, quite technical, forward-looking, and yeah, super interesting stuff ahead of us. My name is Mika Andersson from marketing, and today I'm with Leif Ostrand. And yeah, without further ado, let's give the microphone to Leif and jump right into the signals, shall we?
All right, thank you very much. So yeah, what's this all about, you would say? So we have had this ticket open in the Flow repository on GitHub for, well, since 2018. And over the time, it has actually been the one ticket with the most thumbs up votes. I realized when I was kind of preparing for this, because this is something we knew we should do regardless. But anyways, good to see that the really kind of high-ranked issues are also gradually resolved. So the whole point here, like Marcus asked for way back, is to improve support for what's called reactive programming, basically making it so that you just change the state and then what's shown in the UI is kind of automatically updated based on that. So that's what we're now gradually getting into Vaadin Flow also. The agenda here for these upcoming 60-ish minutes, first going through some theory about reactive state management and signals and stuff. Then I'm going to show a couple of real practical demos on what you can do with it today. And then at the end, going also at the vision of what we think this will become in the future once we add even more stuff to it. And then finally, also plenty of time reserved for questions, and might also get in a couple of questions in between these sections if there are any relevant ones. Does that sound great? Should we get started? All right, let's go. So back in the year 2006, we had this new fancy web thing called jQuery, and it was quite cool in the day. The use case here I'm using is we got a button, and when you click that button, it should reveal some extra part on that web page that you have hidden in some way previously. And the way you did this with jQuery, it's kind of familiar to how you do it in Vaadin. You kind of, in the click listener, you directly have a reference to the component you want to manipulate, and then you manipulate it, in this case, running a show method. And that basically, that's the way it works. Then fast forward a couple of years, and we got this framework called AngularJS. So that's the original kind of Angular 1 version. And it turned everything upside down. And that was quite interesting. The way it worked was that you had in your JavaScript, you described that, hey, we got this show variable, and it initially got the value false. And then you had a separate template file, which was kind of an HTML file, but there were some special attributes in that HTML that Angular interpreted. So you could, for instance, say that when this button is clicked, then we run this kind of like JavaScript expression, though it's more limited syntax, to say that now this module variable named show should be set to true. And then for the div with the message, we had this ng show attribute saying that the visibility of this thing is bound to this same show variable. Then if you go further ahead, React 2013 introduced, didn't look exactly like this then, but the same concept were still there. Again, kind of same, but quite different. Now everything is in your JavaScript or TypeScript file, but it's still the same thing. You kind of declaratively define that this is the state I have. In this case, it's a show variable, and then you also get a setter for it, and the initial value is false. And then you return a data structure defining the component tree to render. So it's got a button with a click listener that changes the state. And then in this thing, you return kind of JavaScript snippet that sometimes it evaluates to this div, sometimes it just evaluates to null, and based on that, that div is either shown or not. And then behind the scenes, React does a diff between the previously rendered thing and the newly rendered thing, because every time you change the state, it runs this function again. So it does a diff between this, and based on that, it finds out how to actually update what's shown. This is a bit inefficient, but it's very practical. So then this was refined. I'm showing lit from 2017, but there's also actually, lit wasn't the first one with this, but that's the one that is most familiar to Vaadin users. So that's why I'm showing that one. It looks very familiar in the structure to the React example. You got a state variable now as an instance field with a decorator. And then you return basically HTML snippet with kind of the same things. The big difference here is that lit is not based on this kind of diffing of the virtual DOM, but instead, in both of the places where you see this dollar bracket syntax, it kind of assigns a hole in the DOM structure. And then whenever you actually have as the values of those snippets is kind of just put into that hole. But then when this is rendered again and again and again, it doesn't touch all the HTML around it. It just puts new things inside those holes, and that's more efficient. And now the thing we have with signals in Flow is very similar in principle, because these signals are kind of, they define the holes, the things where things can change, and then everything around that can remain static and kind of hard-coded. For those signals, we have built a whole new Java API for it, because all the prior art is in JavaScript. So inspired by those JavaScript APIs, but this is our own Java API for it. The first step is to create new signals. So here we create a new value signal, which is the most basic kind of signal, with the initial value of just the number 5. Then one very fundamental concept is a computed signal, which is basically, it's a callback. In this case, we read the value of the signal, the value 5 basically, and then we multiply by 2, and that's returned from this callback. And then the final kind of really central concept is the effect. Effect here refers to kind of that this is a side effect, in the sense that this has an impact on the outside world, not just being kind of limited into the signal space, but actually side effects outside. The side effect we have here is just printing the value of the doubled signal. That value is obviously 10. And when we create this effect, it's immediately run, and that prints 10. And then the real magic is, because this signal, it's not just a static thing, it's a holder of this value. And you could even say it's a magic holder, because immediately when I assign a new value to that signal, so 6 for instance, then immediately that prints 12. And the way this works is, when the effect was created, it didn't just run that thing to see that, well, we should print 10, but also while running through a thread local, it registered that, oh, this callback depends on the doubled signal value. And correspondingly, when that was run, it was registered through a thread local that this computed signal, it depends on the value of the original value signal. So then when we change the value in the value signal, that invalidates that signal, which causes the computed signal to be invalidated, which causes the effect to be invalidated, which causes it to run again, and that's why we see the 12. So that's, in a nutshell, how this reactivity works. Because, I mean, you could very well imagine, instead of printing 10 to the console, you could just as well set 10 as the value of a text label or something in a Vaadin component. There's one more gotcha to be aware of, and that's concurrency and latency between different things. To see this with a simple example with kind of pseudocode, we got an initial signal, or initially we got a signal with the value 0, and then 2 different parts of the system, unknowing of each other, independently do value plus plus. And now we would obviously assume that, well, it's been incremented twice, so first we see that it's 1, and then we see that it's 2. But the problem, like we know, value plus plus is just a shorthand for doing 3 steps. First we read the value, then we increment it, and then we assign it back. And if these two happen to run at the same time, then both might read 0, increment it to 1, and then assign that 1. And then we have a race condition. Then we don't get the outcome that we expect. The way we fix that is to do atomic operations. So we can, instead of doing plus plus, we run a method saying, let's increment this value. And then what happens is that we have received 1 increment and we have received another increment. And in that way, no matter how things are happening concurrently, independent of each other or not, we receive 2 increments. So the value goes first to 1 and then to 2. This is something that is probably quite familiar from the atomic types in Java. So the value signal that I just showed you, it's kind of similar to an atomic reference. You can do just assign the value, you can do a compare and set, and that's basically it. Then we have the atomic integer in Java and number signal with the signals, where you can also increment, decrement values atomically and so on. And then in addition to that, there's also list signal for atomically inserting new values at different positions. And each value in that list signal is actually a value signal. So you can also update any value in any of those slots without affecting the rest of the system. Then there's the map signal, with, again, quite similar to a concurrent hash map. You can do put if absent operations and replace operations and so on. And then finally, there's kind of a bit low level called a node signal, which allows you to do arbitrary nesting of lists and maps and values and basically create whatever data structure you want with that. What are the point really with these signals then? There's a whole bunch of them, actually, I think. First, if you like to think about design patterns like MVC or MVP or so on, then there's this MVVM, model view model concept, which is very close to what signals do, because you can think of, or you can actually use signals as the view model in that kind of architecture, because the whole point is that here you have this model of all the state in the view, and then whenever you make any changes to that view model, then what's actually shown in the view should update based on that. And that's exactly what signals do. So one example, we will actually see almost the same thing in the demo soon, is if you are doing an expense report, then whenever a new expense row is added to the view model, you also want to update the total cost at the bottom of that form that you're filling out. Another use case is to share the view state a little bit more widely, not just within the view, but in the whole UI. This is something you in Vaadin applications usually do with an event bus. But now with signals, there's usually a more convenient way of that. So instead of sharing events, you share a signal instance with the state that should be common between these different parts of the UI. One example of this would be in a web shop, where you have in the header, for instance, there's this shopping cart icon that shows maybe a number badge with the number of items you have in the shopping cart or something. And then whenever you add a new thing to the cart from a completely different part of the application, then the number in that shopping cart should be updated. And the way you can do that then is basically you have a signal with the state of what's in your shopping cart, and then that thing in the header just automatically updates itself based on that state changing. But you can share this state even more wider. If you share it between users, then the signal framework automatically takes care of the things that you otherwise would need to do manually when using Vaadin. So you don't need to do any UI access or pushing or anything. It just automatically, if a signal is updated from outside of the own UI, then it automatically uses UI access to update that other UI. And in that way, in a very smooth way, you can do these kinds of updates to push out changes. So one example of that is when you have an unread message count, then just update the signal for that, and all the users who share that same inbox would get that updated. And finally, it can be shared even more broadly because this is something we haven't yet fully implemented, but it's on the roadmap to also add clustering support. So you can create a signal in a way that the value is synchronized across a whole cluster if you got a deployment with multiple servers. And in that way, you can have full kind of collaboration, for instance, for a support chat that is everyone in the whole application can chat through that. Last part here, before we get to the hands-on details, is a couple of misconceptions that I also want to address. The first is a little bit of confusing with the word reactive, since in the Java space, there's also this thing called reactive streams. It's kind of the same thing in the sense that, well, it reacts to things, but there's a fundamental difference. So reactive stream, that's Flux if you're using, or Flux or Mono if you're using Project Reactor from the Spring team, or then the more low-level Java API is named Publisher. But these reactive streams, they are all about publishing events, whereas these signals that we are introducing, they are about holding state. So that's why they are quite different at the end of the day. Similarly, there's also no direct relationship to the React framework in JavaScript. Again, React works well with signals. It's based on the same reactive approach, but there's no direct relationship there either. Then about collaboration. So I think it's a very powerful way of showing what you can do with signals, to show that, hey, we just share this signal instance between users, and then we automatically got some collaboration use case out of that. But I think that's just cherry on the top, because I expect that signals will be even more impactful just to manage the state inside a single view, or like with the shopping cart, between different parts in the same UI. So it's definitely most impactful for that. And then the possibility of also collaborating, that's just an added bonus. And then finally, signals, they are not a new use case in any way. The use case is very much, I want to share state between different parts of the UI. It's just a new, smoother, better integrated way of handling this use case. And also very important to point out that we can introduce this without doing any breaking changes, because the current flow way of saying that, hey, setting this text on this span or something, that's still very relevant for the for the cases where the text doesn't change. So that still remains. And then also adding on top of that a way of reacting when the text should change. So that's the boring theory part. If we have any questions, then maybe time to address those right now.
Yes, sure. And it wasn't that boring. I thought it was quite interesting background details on signals. First off, please keep on the questions coming as you have during the presentation. We try to address those during the session, but we also have preserved some time till the end of the session, so keep them coming. Regarding the holes that you mentioned, Leif,
Yep.
signals. So at least conceptually, these are only for the front end, or are they?
I mean, you can surely use signals also for coordinating between different backend systems. But in those cases, I mean, sure, you can do it. It's not something we kind of optimize for, but it definitely works in that way also. But also with backend integration, you quite often want to have it even more decoupled. So quite often, I think events are a better solution there. But sure, they can be used also for backend integration.
Cool. That's interesting use case for sure. So creating an effect automatically registers a listener on the used signals. How does removal of these listeners work? Is
Yep.
this through weak references or garbage collection?
We'll address that very soon when we get to the practical details. So I will show exactly how it works there.
Sounds really good. And one more question, the incremental method should be implemented, right?
Yeah, so Vaadin provides a bunch of ready-made signal implementations. There's a value signal, number signal, list signal, map signal, and node signal. And the number signal there has that increment operation already implemented, so you don't need to do that. And the way things work to enable clustering, to enable also interoperability with Hill and so on, means that in practice, it's not realistic that you would create your own signal subtypes, but
Yeah.
instead just basically use the signals as a kind of JSON-like data structure, and then hope that the atomic operations that are part of it will work well enough. And when they don't, you can also, because there's also transaction support, so you can also do things like, let's increment the value here and decrement by the same there, and then only if one succeeds, or only if both succeed, then you actually see the results of it. So in that way, you can also, just with the use of transactions, build different kinds of operations.
Yeah. Well, integers are fairly straightforward things. How about more complex objects? Let's say you have nested attributes and stuff like that. So
Yeah.
how does it work when things get updated and what happens?
Then we get to the more complex types, so list signal, map signal, or node signal. And in those, still within that same kind of tree of signals, everything is atomic, everything is transactional. So you can manage atomicity in that way. Then one thing that we haven't yet explored so much is how do you map that to your Java objects? Because I mean, you have some person DTO or something, and converting back and forth between those, that's still something we're looking into. So that will probably give the second half of that question.
Good. There was also one question regarding the roadmap, but that's one topic that we will cover a bit later.
Yep.
And another comment was regarding the experimental nature of signals for flow.
Yep.
And that is true. It's experimental at the moment behind the feature flag. Could you briefly comment, Leif, on the maturity of the feature?
Yeah. So what the feature flag mainly means is that we are not 100% sure about the API yet, because we just haven't collected enough experience. We haven't heard from you what you find out when you try it in actual real world applications. We have tried it with some more or less made up examples, and it seems to work, but still just being cautious with that. So quality wise, I would say it's production ready, but there is this risk that we will realize that we need to make some changes to the API. And that's why we we have the feature flag there to just warn you that you should be a little bit careful with it.
Sounds good. And that also highlights the fact that we really want you to try this feature out and get your feedback on how it works and how you find it. So
Yeah.
super, super important and helpful. We are actually seeing lots of questions coming in, but to be mindful on the timing, shall we move on and try to address these in the Q&A session?
All right, let's do that. So I'm gonna actually show how you from scratch can start trying out signals on your own. So I'm here at start.vaadin.com. I will not use the starter project with the new walking skeleton because it's got more things that I need. So I'm just going to start a really simple thing here. I'm adding just one flow view that is empty, and that's all there is to it. Downloading this, let's name it signals. Oops, signals, just for fun. Downloading it, unzipping, and then just opening this is in VS Code. Let's run this using HotSwap agent. Need to set that up first, like so. And now we are ready to run this. There we go. And there we have it. So nothing special here so far. What I'm going to do is through Copilot, just enable the feature flag. So here we have features and a long list of things. And here it's the flow full stack signals that I enabled. It tells me we need to restart the server. So let's just close Copilot and go ahead and restart the server. And while doing that, I will actually open the empty view, because that's where all the rest of the action will be. Actually, let's get the browser here side by side. Okay, let's signalize a little bit. Remove all this old stuff. And then first just create a new number signal, because I want to do my favorite demo use case, which is, did I get the right one? Yes. Which is like we have in every, what's broken with, come on, VS Code, clean Java language things. Yes, please. Sometimes it just doesn't work. Now it doesn't work at all. Now it's initializing. But yeah, I was saying this very, very common business use case that you have a button that knows how many times it has been clicked, which is completely pointless, but it's simple enough to really get the point through. And I mean, exactly the same thing could be those, how many unread messages do you have, for instance? Still not getting any syntax highlight, so I would just need to code it manually. This is a number signal count. And now it works. And then I'm going to create this button. And then I need to add it before I forget that. And then add a click listener. And what we're going to do here is we do count increment by 1. So that's, we got the state. We're updating the state. And then the last part, this is something that is still a bit in progress. We'll get to that later. So for now, we create a signal effect to actually update the text of this button. And we do that through something called component effect. And this is where we get to the question about cleaning things up. Because here we give it an owner. We say that it's this button is the owner. And this automatically makes it so that whenever this button is attached, then this effect becomes active and it actually has a listener on the signal. But whenever the button is detached, then that shuts down the effect temporarily so that it doesn't leak any memory. We can also, because this method returns a registration, so we can also do that manually, but in 99% of all cases, we don't need anything like that. For the button, what we're going to do is button set text, and then we're going to give it a format string, and what that is clicks. Let's remove that thing, clicks, and then we want to show that number, but without any decimals. And then finally, one or many signals here, in this case, just the count. So with that, we should have everything in place. Just waiting for the live reload. Why is my server? My server was closed when I reset that thing. So debug, no, there we have it. Debug using HotSwap agent again. Now we got a button that knows how many times it's been clicked. That's great. Let's refactor a little bit. So extract this to method and actually inline this thing also, because one cool thing we can do is that we can create another button using the same state. So now we got two buttons connected to the same state. So when I click one of them, then the count in the other also changes. If I instead say that you actually have your own signal instance as the state, then they are independent from each other. Next thing we can do, actually, let's get that back just because it's cool to see both updating at the same time. Let's make this now also into a multi-user thing. So I'm going to open the application Java and enable push, like so. And then now let's take this count and make it static. So now there's just one instance of this signal for all empty view instances in the JVM. And just with that, I need another browser window. Let's put it so we can see both at the same time. And now we have it so that when I click in one of them, then the state updates everywhere, which means that this other window is also updated. Final thing I want to show is, because usually you want to have many different kind of related signals. So to see that, I'm going to make this also take a root parameter. So implement has URL parameter, and that's an integer in this case. And then I need to implement that method. And I also mark this as an optional parameter. Optional parameter, thank you. And then what I'm going to do is, if it's not given, then just use 0. And then I'm going to move this initialization here. Actually remove that and move these here, which is a little bit weird, but let's do it like that. And then the key trick here is that we have this signal factory with a shared kind of provider. And from that, I can now say, give me a number signal with this and that name. And there I can, for instance, do like this is counts slash and that parameter value. And we assign this as count. So that was a whole bunch of changes. But now we see, now both use the kind of counts slash 0 signal. And we see that both users are in sync. Then if I go to /1 here, now this user has, or this browser window has 1 as the value. So it uses the counts /1 name of the signal that it gets. And then now, if we also take this other window and also go to /1 there, then we see that now they again use the same signal instance because they use the same name for it here. And in that way, you can, for instance, imagine that you have one signal for each order in your database or things like that. And in that way, let everyone in the application who works on that same order instance or something, everyone will share some data or things like that. That's the simple Hello World example. Then I also got a slightly more complicated thing. I'm not going to live code this, but just show what the code looks like. So what we have here is some kind of order management thing for, I don't know, spaceship parts or something. And here we have two parts are already kind of about to be ordered here. And for each of them, we have the amount and then the unit price and then the total price for that line. So if I change the number here, then this total also changes. And then here at the bottom, we got total number of items, so 2 plus 5, and also the sum of all the prices. And then finally, we can add another product here. And well, it's just added, and we can also remove products. And whatever we do here completely automatically, this summary is always up to date with the values. And the trick here really is, this is all in just one big messy Java class. So we got the actual data, some sample products, yeah. And then we got a list signal with the order lines, put some sample data in it. And then we create computed signals using the .map shorthand. One for taking all these order lines, getting that basically as a stream of value signals, getting the value out of each of these signals and mapping that to an integer based on the quantity and summing that up and correspondingly for the total price. And since what happens here is that this computation callback, it runs .value on all the value signals inside the list, which means that whenever any of those change, the value of this computed signal will also change. And as we see here, I'm also here creating a component effect to format that summary based on both the item count and the price. For the list of components, this is again something we will improve, but for now, a little bit inefficient, but very, very kind of practical. I create an effect that reads the value of that list. So that's a list of value signals. Then it removes all previous children and then adds a new one for each of the order line items and giving this that signal to the component for that. And in that way, they kind of, each line knows the data that it should be using, the state that it should be using. And then finally, and I think this is the coolest thing, when we add a new order by selecting it in the combo box, all we need to do is we update the state. We say, now we got one new order line with the selected product and the quantity one. And then based on that, the UI is automatically updated, creating the new order line component for it. In the order line component, it's basically just the same thing, a whole bunch of computed signals for the things that can change, binding the integer field value. This is something we should create a helper for also, but we're not there yet. Binding it so that when we get a change event, we also update the signal value, but we need to do that in a way to avoid infinite loops for now. And then the actual update, it's basically just creating a new record with the same product, but a different quantity. And that's basically it. Last thing I want to show is that I think this is a little bit chunky because this kind of component effect.bind, it's quite much code. So what we will do, it's not done yet, except in my own workspace. But what we want to do is that to the span constructor, what if you just give it a signal? Same with this kind of formatting thing. So what if you just give it a format string and some signals to use as the input for that? So if we save that and have a look, then everything just works as expected. And similarly also, this thing doesn't look like something we would want to have in application code. What we really want to have is the optimized version. We just give it the list signal to bind to and the constructor that takes the child signal to use. And just based on that, we now have a much cleaner UI code that actually just said that, well, we got a diff using these lines and this component to represent each of the lines. And that's all we need to say in application code. And it still works so that if I add a line, it's added. If I remove one, then that component is removed and so on. Cool. Those were the practical demos. Next, should we take questions or maybe save them to the last just to make sure we get through everything I want to tell?
I'm very much tempted to take a few questions, but let's just move on.
Let's take one or two.
Oh, one or two.
Yeah.
Fair enough.
No pressure. Just pick the best ones.
I'll go by the order of arrival. So first question is, I have a type of shopping cart app. In short, the order lines are complex. We add hundreds of them, and all of them takes multiple seconds. We started using Mono and Flux to handle the backend. Being a backend driven, we ended up using lots of UI get current. Could the signals change, or could signals change this within a Flux?
Yeah, so what you can definitely have is that you have a subscriber to that Flux, and what it does is that it updates the corresponding value in the signal based on whatever you have received from the Flux, and then what you have in the UI will update itself immediately based on that. So that's one way. Another thing would, but potentially, I mean, I don't know about that architecture, but you could potentially maybe even just remove the Flux and just use signals throughout. But both options are valid.
Cool. Let's take a few questions regarding performance and memory consumption. How many signals can be placed in memory without any issues?
How much memory do you have? I mean, one signal, it's like 100 bytes, 200 bytes of memory. So plenty, I would say. I will actually come to one thing at the very end of the vision. We got these stateless components there, which are really cool. But in general, I mean, if you have an event bus or something and manually add and remove listeners, then you also use memory for tracking all of those things. So it's roughly the same, I would say.
Okay. How about comparing signals to traditional methods of tracking changes? Do we have any data about that? Do you know?
Do you mean performance wise, or
Yeah, performance wise, yeah.
I haven't looked into that. Again, it's fundamentally it's the same amount of work happening. There's behind the scenes, there's an event being fired, and then you keep track of the listeners for that. So probably roughly the same. There's another kind of level of abstraction here, which adds a little bit of overhead for sure.
Hmm.
And then it's always, but I mean, to be honest, in most cases, your bottleneck is the database, not the UI layer. Or if it's the UI layer, then it's the things happening in the browser or the communication. And that's exactly the same. Whereas the just kind of number crunching kind of CPU consumption in the UI layer, it's very rarely the main bottleneck you have. So it's in most cases it's fine, but definitely you should measure and make your own judgment there.
Yeah. Cool. All right. Let's move on, and I'll be saving rest of the questions for the Q&A.
All right, thank you. So roadmap wise, like said, in Vaadin 24.8, which was released a couple of weeks ago, we introduced the things that I showed you just recently. It's beyond a feature flag. We plan to, as the next step, get the component APIs also updated. And then beyond that, there's lots of, I would say, quite exciting things we should also do, because in a UI framework, everything you do is related to UI state. And my experience with playing with these things so far is that whenever you do anything then that is not signal enabled, then you're kind of, oh no, how can this be so complicated? So we really want to make everything signal enabled. It will take a while to get there. I'm not making any promises here, but just saying that these are things that we expect to get done one after the other, and how quickly that happens depends on how much awesome feedback we get from you and what other things we do in between and so on. But the first thing is routing. So I think it's one quite cool thing we could do is if you got some nested routes, like in this case, kind of we got customer number 123, and then each customer has a bunch of deals, and now we have deal number 456 selected here, and that somehow affects what we have in the UI. Then what if this navigation state of the view would also directly be a signal? So one way of doing this is if you would, I mean, this is a made-up API. I'm not sure this is how we will do it, but just one inspiration example. What if we would have this view state with a customer ID and a deal ID, and then you could also optionally put prefixes, kind of root prefixes to this. So just based on this, you can really read out it's kind of customers slash customer ID deals slash deal ID. And that would be the URL for it. And then we could have a view class with just at route without any pattern or anything like that. Implement some interface like has view state saying that this is the record containing the view state and also implicitly the pattern for the URL. Then what could happen with that is has view state gives you a get view state method that you can run, which returns a signal. You can do a computed signals for all the things like the deal ID, for instance, and then you could use that deal ID for populating the UI, or not populating, but on the fly configuring the UI in quite the same way as I did with the order form also. Of course, you would need another computed signal that fetches the deal from the database based on the ID and so on. But the cool thing here would be that you wouldn't need to do anything when the user navigates to a different deal ID, because the framework could just put a new view state instance in the signal, and then through that, everything else would just update. And this could also work the other way around, so that when you are in this view and the user selects a different deal, all you would need to do is to say that, hey, let's update the view state. Let's create a new instance with the same customer ID, but a new deal ID. And based on that, the framework would update the URL in the browser, and there would be a signal value change. So all the things that you have derived through this computed signal would then also automatically just update. So that means that in that event listener, all you would say is, now we change the state, and then everything would be updated based on that. Of course, access control and so on, but the kind of state manipulation would be optimally this simple. Another use case is definitely form binding. We already have the Vaadin binder, which is reactive, but there's more things that could be reactive there. And I think there's kind of three different directions here. One is reactive between the UI component and the binding state you have, so that if the value in the binding is updated, then the component is updated, and vice versa, and so on. And you could also manipulate these outside of the binder if there are such use cases. Next thing is kind of downwards in this diagram. So if each binding also has a touched state, change state, those are just booleans, then for the whole form, you could also very easily have a computed signal that is any field touched, is any field changed. And that's something you might want to bind to whether the reset button is enabled or save button is enabled and so on. And then finally, also some opportunities for signals towards the business layer, the services. So you would want to have maybe just a signal for saying that this is the selected item, and then the binder would update itself based on that and so on. But I think the most powerful thing is, in the context of form binding, is cross-field validation. So in this simple example, we got some kind of event form for creating a new event. And we got the binding for the start field of that event, not showing how that is done. But key point is, from that binding, we could get a signal with the value of the start field. And then for the end field, we could create a validator. It receives the value of the end field. And then what it does is that it uses just kind of local date time checker. Is this end value after start value, or the value of the start signal? And the magic is, like you saw with the other kind of computed signals, whenever a signal value that is read in a computation changes, then that computation runs again, which means in this case, if the with validator method is signal aware, it would automatically update the validation state of the end field whenever you change the value of the start field. So you wouldn't need to manually tell the framework when the start field changes that now we should also update the end field validation, but it would just work automatically. And the same also, of course, with the error message for the validation. There also, if you use any signal there, then if that signal value changes and the field is invalid, then the actual message shown in the UI would just automatically update also. Then finally, kind of, this is very, very speculative. I'm not sure we will ever get here, but if we would, it would be quite cool. Because one observation is that when you're using signals, if you do kind of everything by the book and you use signals throughout, then all the state of your view, all the state of all components would be captured in these signal instances. Then in the constructor for that component, you create the kind of component structure, and then you bind everything to signals. But you wouldn't in any place, in any event listener, you wouldn't directly manipulate any component instance. And from this follows this really cool thing that the component instance could be a singleton. Only thing that changed is that this number state thing that we get through this singleton-based component class that I invented, this number state would always be bound to the current user session. So for different sessions, this same singleton signal instance would have different values. But the logic for how it's bound to the UI would always be the same. When we do increment by in this example, because I mean, this is the same example that I just live coded, all we do is indirectly update the value in the session, and then nothing else than these few signal values would need to be stored in the session. And this could even be taken further. So these few signal values, they could be stored in Redis or some external system, so you wouldn't need any server-side state at all. They could even maybe be passed just through request and responses with some encryption or something to avoid tampering, but still just completely statelessly passed back and forth, but still your UI logic would look like any other flow logic with signals, with everything just set up in the constructor and everything bound to signals. Like said, no promises definitely about this one. The two other ones I'm quite sure we will do. This one is still a little bit iffy. We need to really see if it makes sense based on prototypes once we get there. Now I'm done talking.
Awesome. Great stuff. I think I followed quite well up until the vision section. It started to get quite deep. Really interesting. Yeah, we do have a few more questions that we haven't been able to address so far. So let's start from the ones that we received during the first section, the theory part.
Yep.
Here we have a user of Vaadin 7. Replacement for Vaadin 7 properties, question mark. Each cell in form or grid, it separates signal.
Yes, very much.
In the signal anatomy code example, the effect was invoked in the signal class. How does it relate to the signal created before?
So we're here.
Yes.
And could you repeat the question?
So in the signal anatomy code example, the effect was invoked on the signal class. Question mark.
Okay, I got it. So this is static method, because one thing that I didn't really show in an example here, but a signal effect can depend on many signals. It's not just necessarily one, which means that you wouldn't want to do just, I mean, maybe we should add some shorthand kind of signal.effect that just receives the value of that signal. But the powerful thing is that you can have a single effect depending on many signals, which means that this needs to be a static method to be able to track all of them not being tied to just a single one. So I think that's what this question was about.
Yeah, and here is a related one. How does signal effect understand what the dependencies are? Is it a global execution of, after all?
Thread locals. So
Yes.
basically, whenever .value is run on any signal instance, it checks a thread local to see, are we run from inside an effect? And if that's the case, then the signal marks itself as a dependency for that effect. And that actually means that you can even have nested effects, and it will always be the innermost effect that is the one that gets the dependency.
Got it. All right. Moving on to the coding section, we had a few questions. So do signals run purely on the server side, or have they a client-side representation as well?
Everything I showed here is purely server side. So if we, actually it was somewhere here. No, I need to jump here. So for instance, actually, if you get back the old code there, for instance, so what we have here in this effect is directly just saying that we should run the regular span.setText method whenever any of these two signals change. So everything from span.setText onwards works in exactly the same way as if we would just directly do price span.setText foo or whatever. So in that sense, there's nothing associated with the client side representation here. At the same time, we do also have signals in the HILA framework. And in that case, the whole point is that from a HILA endpoint, you can return exactly the same kind of signal as these. Currently not, but we will update them to use the same types. And then you will able to share state between multiple HILA users, or even between a HILA user and a Flow user through that signal, and it would just automatically work. So for that, there's also client-side implementations of the signals in HILA, but that's nothing that is used through pure Flow.
Got it.
Maybe in the future we could optimize things further by just passing the signals instead of saying that it's a span text that's changed, but that's again quite far into the future, I think.
Yeah. Okay. Do we have these code examples somewhere available, maybe in GitHub?
Not these exact examples, but I posted in the forum on the Flow section just a couple of weeks ago. I think we could share that link also. I posted one kind of, here's how to get started with signals, with showing exactly that same click button and also showing the order form example. So those are in that forum post.
Awesome. Yeah, that was a really thorough forum post, so I highly recommend you to read it. It's super informative and helps getting started with signals.
Yes, and if you got additional thoughts, then that might be a good place to put them also.
Absolutely, yeah. Well, I think that was all the questions we had. There were two kind of funny observations. The first one being that how long will it take before we are seeing all business applications in just one line, as we are abstracting things so much? And another observation was that, yeah, the world is turning into a signal, that's for sure.
I mean, it would be quite cool, just kind of new business application and then pointer to the database, and then you're done. But I think we'll need some AI also, not just signals, to be able to do that.
That's true. Cool. Hey, we are through all the questions. Can we move on to the second last slide as you're controlling?
Actually, I saw a very interesting question pop by right. No, actually, it was an old one. I have things scrolling. Yes, we can jump to your advertisement. No, actually,
my advertisement. Well, this is for all our guests here in this webinar. So we are doing Vaadin Create 2025 in the end of this year in Frankfurt in October. And as a thank you for being being a part of this webinar, we'd like to give you a promo code with a 20% discount. And the promo code will be valid till the end of, or not end of the next week, but till Friday next week. So till July 18th. And yeah, it'll be a great session, or multiple sessions, one of which is going to be hosted by Leif on signals. So we are going to get much deeper into this topic during the Vaadin Create and many other interesting Vaadin related discussions and presentations.
Yeah, the topic then on my behalf is thinking in signals, which is really more about kind of what are the things you should do differently in your existing or compared to your existing applications? How can you kind of get started with actually thinking about things in a reactive way? Because that's one thing I have seen quite often when people start trying out signals. They run into these weird bugs that come from just applying non-reactive approaches to signal usage. And I mean, for better or for worse, there's some things you just need to kind of learn to stop doing when you start using signals. So that's the topic of the signal presentation at Vaadin Create.
Sounds super interesting. But with that, I'd like to thank all of you. We've got quite a few questions here in the pipeline, which we weren't able to address. Some more were just coming in. However, feel free to ask those questions on forum. There is a link here on this slide. And yeah, any questions you might have regarding Vaadin, the forum is an awesome place to get started with. And yeah, with that, thank you. Have a great day, and till the next time. See ya.
See you.